All right, hey guys, Mr. Kyle Myers Mathematics, and let's just jump right into it. This is a worksheet on excluded values. So, what they mean by that is values for whatever the variable is that don't work. Like if you were to plug in that number everywhere there's a letter, then it would result in something that's not a number anymore. It's kind of weird maybe to think about it like that, but I'll show you what I mean. So with this one, with number one, I'll just tell you what the excluded value is. So I can show you what that looks like when you plug it in, right? So the excluded value for this one is 0. And of course, I'll show you how to do that and how to get that number in a second on number 2. But on this one, let's just go ahead and plug it in and see why that's a problem if I plug in 0. So if I plug in 0, I get 30 times 0 minus 20 over 90 times 0. Okay, 30 times 0 is 0, minus 20. 0 minus 20 is negative 20. 90 times 0 is 0. Okay, so negative 20 divided by 0. What, what is that? Well, you might already know the answer, but I would maybe venture to say that not everybody knows why the answer is nothing. The answer is nothing because when you divide, so let's say you have a box that can hold 20 of something, 20 smaller boxes of the same size. All right, so this box can hold 20 of smaller boxes of a particular size. Then we could say that box is a 20 box. All right, so that's the top number. If I divide 20 by 10, what I'm saying is how many little boxes how many groups of little boxes could I put into the 20 box if I have 10 of them, right? 10 at a time. 20 divided by 10. How many 10 boxes will fit into a 20 box? Two. Two 10 size boxes will fit into a 20 size box. All right, so 20 divided by 10 is 2. 20 divided by 2. How many 2-sized boxes can fit into a 20-sized box? 10. Right? So I think you get the picture. The reason why this is a problem then is because what it's really saying is how many 0-sized boxes will fit into a 20-sized box? Well, in a way, infinity, but in a way, nothing, because there's no such thing as a 0-sized box, right? That's not even a box anymore. So it's just a non question at that point, which is why we say that it's nothing, or a 0 with a slash through it is how I normally write nothing. So 0 then is the answer, because when I plug in 0, I get nothing. That's the excluded value. K cannot be equal to 0, because if it is, then the denominator is 0. It doesn't matter what the numerator is. If the denominator is 0, you get a non-answer. Any number, any sized box, can fit an infinite number of nothing into it. So it's just kind of nonsensical for certain values. Well, then, if the point then is to set the denominator equal to 0, then that's all we do. So for excluded values, if you have a fraction, and I believe all of these are fractions. I think when I looked over it earlier, it looked like they were all, yeah. So they're all fractions, right? If they're all fractions, then what you do is you just set the denominator equal to 0. So the denominator, such a long word. Set it equal to 0, and solve it. So you would just have to set 90k equal to 0, solve it. You divide both sides by 90, 0 divided by 90 is 0. Whew, that was still a little fast. Let me show you what I mean on number 2. So in order to find out what the excluded value is, I set the denominator equal to 2. Or sorry, equal to 0. It's going to be equal to 2 in a second. Getting ahead of myself. Set the whole denominator equal to 0. And then solve it. Well, in order to solve it, I just add 2 to both sides, right? So add 2. And I'll go a little bit slower at the very beginning of this worksheet. And pretty much every worksheet, this is what I do. I just go a little bit slower in the beginning, so bear with me if it seems a little bit slow for you. Then you can either, scrub ahead a little to where I start to pick up the pace, or you can play it at a faster speed if you want. Either way, if it seems a little too slow for you. But I start out slow on purpose. That way I don't lose anyone at the beginning when we're talking about the fundamentals. Okay. So the answer to number 2 is 1/3. Right? And that's really it. You just set the denominator equal to 0 and solve it. Okay? So, I mean, obviously, it gets a little bit more nuanced than that. I mean, like if I do this one's not that different. Okay? I'm going to go ahead and skip the in-between steps. I would subtract 27 on both sides. Divide both sides by 27. I did show that step. I don't know if I meant to or not. X equals -1. So that's the excluded value, right? Now what about for number 4? 63 is the denominator. If I set that equal to 0, can I even solve that? Is 63 is not equal to 0? Hold on, right? So, I mean, if you subtract 63 on both sides, you'd get 0 equals -63. If you divide it on both sides, you'd end up with like 1 equal to 0. There's no x, or the letter v, I guess, on number 4, but there's no letters, there's no variables in the denominator. Well, if there's no variables in the denominator, then there's no way to have the denominator equal to 0 unless it already was, which I've never seen a problem where they already have the denominator equal to 0 at the very beginning. Never seen that. If you have, let me know in the comments. This one doesn't have any letters in the denominator, so there's no number that could be plugged in to the letter to make the denominator equal to 0. So there's no excluded values. No excluded. And I just write in cursive just because it's less laggy. Excluded values. So I apologize if you can't read cursive. It says no excluded values. It's a little bit sloppy. Okay, moving on. Number 5. Now, if you are very smart, or if you just maybe overthink things sometimes, I know I do, you might think, well, this numerator does factor, right? So if you are somebody who didn't think of this, then you can scrub ahead a little bit. But if you're the person who maybe got stuck on number 5, and you're like, why is the answer 9 when it cancels? Here's why. If I cancel this, right? So in the numerator, it would be p minus 9 times p minus 9. Or you could write it as p minus 9 squared. It doesn't matter that much. Just depends on how picky your teacher is, I guess. So then the p minus 9's cancel, and you have p minus 9 left over. Okay. Right? So, and I won't box that because that's actually not the answer. So you get p minus 9 left over. It doesn't have a denominator anymore. The denominator would be 1. So, I mean, I guess it has a denominator. Everything has a denominator. You can write everything divided by 1. But 1 cannot be equal to 0. And so maybe you might be thinking, well, then there wouldn't be any excluded values on number 5, just like there weren't any on number 4. And you're kind of right, you're kind of wrong, mostly wrong. Here's why you're kind of right. So you're kind of right because there isn't the same kind of domain restriction anymore in the denominator. If a denominator doesn't cancel out, then that is going to result in what's called a vertical asymptote. That's a certain kind of domain restriction. If you do cancel it, like we just did here for number 5, if you do cancel it, the p minus 9's, there's no longer a vertical asymptote domain restriction. Now it's what's called a removable discontinuity, or a hole. When you cancel out something from the numerator and the denominator, it creates a hole in the graph. That's still a domain restriction, though. And that's why you don't need to worry about canceling stuff. Not for this worksheet, at least. If they just want the excluded values, which is the same thing, really, as asking if they want the domain. Basically the same thing as asking for the domain. That's really the other thing that they're asking here on this worksheet. 9 is still the excluded value for number 5. Because even though I canceled p minus 9, it still creates a hole in the graph, which is still an excluded value. It's still a domain restriction. All right? So moving forward, this is actually good news, because that means we don't have to do anything with the numerator. You don't need to factor the numerator. You might need to factor the denominator, but you don't need to ever factor the numerator, because even if it did cancel, it wouldn't matter. It would just create a different kind of excluded value, but they don't want to know the different kinds of excluded values. They just want to know what the excluded values are. And that is good news. That makes this worksheet a little bit easier, actually. Separate out some of the work here. Okay, so for number 6, all we're going to do moving forward is we're just going to take the denominator. I don't know why I wrote an R. We're just going to take the denominator and set it equal to 0 and solve it. Right? If you set it equal to 0 and solve it, you normally just do SADMEP, the opposite of PEMDAS. The order of operations, PEMDAS, backwards is the order of operations for solving. But if you have two different kinds of x's, then you have to factor it out first. So let's do that. We can factor out a 2, but we don't really need to. I'll go ahead and factor out a 2. I think it might make it a little easier, perhaps. So then what's left over will be, almost wrote a 16, 8, right there. So now that it's factored, and 2x doesn't need a parentheses, but if I write a parentheses there, then you can see, hey, set everything that's in parentheses equal to 0, right? So set that equal to 0, and set that equal to 0. So then x equal to 0. There's a domain restriction, or an excluded value. And then over here, if you add 8 to both sides, and then divide by 7, you get 2 excluded values. So now we have 2 excluded values for number 6. There's no limit to how many excluded values you can have, by the way. Just if you have a really big denominator with a really high degree, then it's possible to have a ton of excluded values, and that's just really all there is to it. 5 minus a equal to 0, minus 5 on both sides, get rid of the negative, and that's it. Right? And that's really all it is for all of these problems. 27r equal to 0, divide both sides by 27. 0 divided by 27 is still 0. There we go. All right, 27 in minus 54. Add 54 to both sides. 54 is 27 doubled. So when I divide both sides by 27, I get 2. All right, x plus 10. Subtract both sides by 10, right? So 10 minus 10 on both sides. Right. Pretty easy peasy so far. Right, now that we've hashed out all the different details and things that I think you might get stuck on at the beginning there. So we are starting to pick up the pace a little bit here now. Until we run into something that's a little new. Nothing is really new right now. Everything is pretty much the same. Right, just divide both sides by 20. Everything's pretty basic so far. Nothing real crazy yet. We'll run into something like that soon though. This one's exactly the same as that other one. Subtract 6 on both sides. Divide out the negative. 40k. Oh, and by the way, if you like this video, if this video has been helpful so far, then, you know, of course, just like any other YouTuber, go ahead and give that a like and a comment and a subscribe and all the things, you know. But really, other than that, I mean, go check out other videos and see if they could be helpful towards you, to you, I should say. And if they are, then awesome. And if they're not, let me know in the comments on this video or any video how I can be more helpful. Or maybe there's just a certain problem that I haven't solved or a certain topic I haven't covered yet. And let me know. I'd love to do a video on whatever you want me to do a video on, really. That's it for that one. That was a little harder to do mentally. Mental math there. 6 times 8 is 48. 5 times 8 is 40. Whew. Work on my times tables. A little slow on those today. And other than, you know, looking at other videos that are in the channel, go check out my website. And I've got all the videos like this on there. And I've also got a bunch of other stuff too that's not on YouTube. So go check that out. On the main page on myersmathematics.com, there is the 5 math mistakes everyone makes and how to avoid them. It's not a video, it's like a document, like a PDF thing that you can just download and well, it actually gets delivered into your email box. But you can grab that, open it up, and it's basically just a little, you know, like here's the 5 things that people typically miss in math, and here's how you can not miss those things, right? So go grab that free guide. It's pretty awesome, I think, and let me know what you think about that as well. You can do that in any one of these videos or on my website. So go check that out. So myersmathematics.com. This one is a factoring problem. We do have to factor again. So we want to factor out the 14. We want 2 things that multiply to 14. And they subtract, since we got negative 14, we want to subtract to 5. Right? If the last number is negative, then the factors have to be positive and negative, which means that you'll be subtracting to get the middle number. If the last number is positive, then you'll be adding to get the middle number. Okay? The middle number could be positive or negative as well, but it doesn't really matter too much the sign of the middle number. It matters more the sign of the last number. And of course, I've done a ton of work with factoring. I think I have more videos on factoring than I have any other type of video. So I've got lots and lots and lots of videos on factoring. Go check out some of those. I've got very specific examples, very short videos on some of those as well, so you can go check those out too. But I digress. We want 2 things that multiply to 14. The reason why I just mentioned that you should go check out the factoring videos is because I'm not going to dig deep into how to factor. I'm just going to kind of factor it. Okay? So if factoring is something that you're a little rusty on or just not so great at yet, go check out some of those videos. That will be where I kind of go take a deeper dive into this. But the factors are going to be 2 and 7 with the negative on the 2, positive on the 7. Okay? X equal to 0, and my 2 answers are going to be 2 and negative 7. I don't ever need to check any of these answers. There's not going to be any kind of extraneous solutions, because remember, if I plug it back, I'm looking for the extraneous. I'm looking for the extra, so to speak. So I don't need to go back and check anything. Unless I wanted to check my work and make sure my work was good. But other than that, nah, nothing. Positive 9, negative 1, in equal to 0, in is going to be equal to 1, and negative 9. All right. Again, with 18, we come back to kind of an easier version here. In is equal to negative 1. All right, so now that we're already probably almost done, it's crazy how fast this worksheet's gone, because look, 1, 2, 3, 4, 5, 6, 7, 8. We only got 8 more, because look, there's the answers. Right? So only 8 more. So only 2 more sets of colors here, like a deeper orange and then a red. I'm going to end on my least favorite color. And that's it, right? So that's really all there is to it. I'm going to ramp it up a little bit more, though, as we go, these last few. So I'll still set it equal to 0. But I'm going to go ahead and factor it. 15x and then I'll jump straight into the answers. X is going to be equal to 0 and -2. And that's because if you have a something times an x on the outside, then that's a 0. And if you have something plus or minus a number on the inside of a parentheses, it's going to be the opposite of whatever that number is. It always works like that. Over here, it's going to be the exact same thing. Plus 45p. I'm going to subtract the 45p. Oh, no, I'm not. Just kidding. I keep wanting to do Control Z and it doesn't, I forget it doesn't work on here. Not on this thing. I'm going to factor it out. Got ahead of myself. P plus 3. So that means P is equal to 0 and -3. All right. And don't forget to say that it's equal to, not equal to. I was trying to think of a better way to say that. Don't do the equals with the slash through it. That's for when you're saying what the domain is. If I was going to say what the domain is, thinking that these are functions, then I would say P cannot be equal to 0 or -3 because it results in a bad thing. But what they're asking is to find the bad things. So we're setting it equal to these numbers. All right, so -8r plus 12. The factors are going to be 2 and 6, but I want them to be -2 and -6, so my answers are going to be 2 and 6. All right. Ooh, okay, this one's a little tougher. Probably won't solve it all in my head like I just did on the last one. Now we're getting a little cray-cray here. So I'm going to factor out a 2x, and then I'm going to have x squared minus 10x plus 25. I don't know why I was thinking 2 or 10 for some reason. 25 equal to 0, and then 25, that's going to be 5 and 5, but it's going to be -5 minus 5, which is the same exact factor. That's a square factor. So -5 minus 5, you all have a 5 and a 0 for this one. Now on this one, I could have had 3 answers. Whatever the degree of the denominator is, that's how many possible answers there are, but not guaranteed. All right, now we're on our last set of 4, and we're on to like a, is that red? No, it's like a red-orange. Okay, not quite red. Red is my least favorite color. Just don't like that color. Plus 33 P2 plus 12P. So many P's. Let's see. 3P. Right, so 3P is the GCF. P2, ooh, this is not going to be a fun one. 11P, 4 equal to 0. This one I wouldn't recommend doing in your head. Not until you get a lot of practice down. I could probably do this one in my head if I wanted to, but I'm not going to because I haven't done a factoring problem of this kind yet. So actually, I'm going to go ahead and off to the side here. I'm going to write P is equal to 0 because I know that's one of my answers. Then I'm going to just focus on this inside stuff here. So you want to multiply these guys. Then you want factors of 28 that give you 11. Well, 7 plus 4 already gives you 11, so it's 7 and 4. But here's what you do. You go 7P, 7P, and then you set each one, well, actually, yeah. So then you just set each one equal to 0. So I don't need to divide this by 7. If I wanted to have correct factors, I would need to divide it by 7. So the trick to factoring, when you have a number in front of the square term that you can't like take the GCF out of, take out a GCF and have it go away, like we did on number 22. If you have this kind of problem, this is how I normally factor it, and I would normally divide this by 7 because I have an extra factor of 7 here, but I don't need to if I'm trying to solve it for 0. I don't need to. I just do it. I just get the answer. So I would set each one equal to 0 and solve. I'd get 7P equal to -7, and then divide and get -1. Right, so -1. And actually, let me erase because I'm gonna need some space for 25. And then for this one, 7P plus 4, I would subtract 4 on both sides and then divide by 7, so that's -4/7. Ooh, okay, that was a doozy. For sure. And there we go. Okay, so to recap, on 23, it was just like 22 at first. We factored out something that had a number and a letter, so the GCF was both a number and a letter. Then what was on the inside we had to factor still. So 22 and 23 had that in common. However, 22 was a regular trinomial, which means there's no visible number in front of x squared. Versus 23, once we took out the GCF, we still had a visible number in front of the x squared term. In this case, it's a p squared, but x squared. That's x is the normal letter. In order to factor that, you multiply a and c, the first number and the last number. Then you find factors of that give you 11. Then you create 2 extra factors of the number in front of the squared term. And then you divide out the GCF. Not factor out, divide out. It just goes away. Divide out the GCF from one or both of those binomials. Right? And that is what I like to call 2 truths and a lie factoring. It's really probably more likely to be called at least one lie out of two factors. But that's a lot harder to say. And 2 truths and a lie is the name of an icebreaker game. So I just named it after that. But that is something that that I came up with. Not really all on my own. I kind of got some inspiration from somebody else and then kind of made it better, is what I did. So can't take full credit for it. All right, moving on. 24. 2x squared plus 6x minus 8. This one's not going to be that bad again because I'm going to be able to factor out that 2. Plus 3x minus 4. Yeah, this one's not that bad. And the 2 is just going to go away because 2 cannot be equal to 0, right? So that's just going to drop off. Then the factors of negative 4 are going to be positive 4 and negative 1. So my answers are going to be negative 4 and positive 1. Negative 4, positive 1. All right, so 24 actually wasn't that bad. All right, 25. Ooh, I've got 4 things. Well, if you have 4 things, then you either have to do, so worst case scenario, if you have 4 things, worst case scenario, if you have 4 terms, would be having to do long division of polynomials. That's worst case scenario. Slightly less than worst case scenario would be synthetic division. But the best case scenario for this, if you have 4 terms, other than a GCF, would be factoring by grouping. And that's what we have here. So factoring by grouping only works if you have a composite number of terms. Composite is the opposite of prime. We have 4 terms. 4 is the first composite number. 4 is 2 equal groups of 2, right? So what I do then is I group them into 2 groups. And then I do GCFs. GCF, GCF, GCF. I do 3 of them actually. 1 for each, and then a GCF of GCFs. Okay? So take out the GCF of the first group. Take out the GCF, including in a leading 0, or a leading negative, I mean. So even if both of them don't have a negative, if the first one has a negative, I would take out the negative. Be careful with the sign of the second one, though. It should be the same if it works. If you are doing a worksheet on factoring by grouping, then every one of them should work. You're not guaranteed to have factoring by grouping work, though. It just happened to do it on this one. Now, what happens is I factored out r minus 1, I factored out r minus 1, so that means I can factor out r minus 1 from both of the resulting terms. And now I can set each one equal to 0 and solve it. And you might be like, oh, wait, hold on. But you could keep going. You could keep factoring. And you're right, you could keep factoring. 1, I don't have a lot of space left over. And 2, I don't need to. The only time you need to factor is if you have more than one kind of x. I don't have more than one kind of x anymore, not for each factor. This r minus 1 only has one kind of x. So r is equal to 1. Boom, done. The second term, r squared minus 49. That only has one kind of x. It's a different power of x, but it only has one kind of x, not two different powers anymore. So I could factor it. It would be r plus 7 and r minus 7. It's called a difference of squares factoring. So kudos to you if you knew that, and if you were thinking to factor it further. You don't have to factor it further, though. You could just set it equal to 0 and solve it. Now, you'd have to be careful, though, because if I add 49 to both sides and I take the square root of both sides, when you take the square root of both sides in an equation, you have plus or minus that number. So I'd add 49 to both sides, take the square root of 49, it's 7. But when I take the square root of both sides of an equation, I do plus or minus. So the answer would be plus or minus 7 on top of that 1. All right. I mean, it is a standard worksheet. It gets harder as you go, right? All right, last one. Last one. Here we go. 3a3 minus 3a2 minus 18a. This one is not going to be as bad as 25 because I can factor out 3a. A squared minus a minus 18. And then this is just regular factoring. 18 is 1 times 18, 2 times 9, 3 times 6. And that's it. So does it factor? Maybe it doesn't. We know that one of the answers is 0 because of this, 3a. But does it still factor? So what I mean by that is I couldn't think of integer factors. There doesn't seem to be any integer factors. I'll check again. 1 and 18, that would subtract to 17. No. 2 and 9, that would subtract to 7. No. 3 and 6, that would subtract to 3. Oh, hold on. If you stuck with me until just now, I appreciate it. I just did a boo-boo. I did not factor out I didn't divide the 18 by 3. That was dumb. There we go. That will factor. Okay, thanks for sticking with me if you did. If you didn't, boo. Boo. Because, you know, people make mistakes sometimes. But hey, I caught it. I was like, hold on, why am I not factoring factors of 18? Because that wasn't how it was supposed to work, Kyle. Alright, so 18 divided by 3 is 6. There are factors of 6 that work. So this one is actually easier than 25 after all. We would do 2 and 3. I would want positive 2 and negative 3. So my answers are going to be negative 2 and positive 3. Negative 2, positive 3. And there we go. That is the end of that worksheet. And so if this worksheet has been helpful, of course, go ahead and share it. Go ahead and like it. Go ahead and look at other free stuff on YouTube from me, from others, anything that could be helpful. I hope that if you are watching this worksheet, listening to this worksheet, that you are able to find the answers you're looking for to your math problems. And you are more than welcome to go check out my website for more content over there as well, myersmathematics.com. I'll be putting more and more different kinds of things on there throughout the years. So go check that out. It's awesome. And I hope you have a great day. I'll see you in the next video.